Okay, and now let's see what will happen in each box. Oops, I don't know why I don't have one of my slides. Okay, no matter. In fact, at the first time we have the expansion permutation. What will happen here in this stage? In fact, here you can see the main block, and for each row you can see we add one in fact bit at the left and one bit on the right side. But how it could be happen? Here you can see in this picture, oops, sorry, maybe more clear. Here you have your 4 bits. In fact, your 32 bits is split into 8 subblocks, and then for each one, as you can see here, you will have the expansion box. These 4 bits are replaced one by one. We have 2 in fact empty place on the left and on the right side, and as you can see here, on the left side we can fill with the last bit, the bit of 32 here, and here the 5th bit will be replaced here. It has been shown here. Okay, and these steps continue as well. And here, as you can see, for the second part we have 2 empty place. The left place will be replaced with the 4th bit here. The 4th bit which will be replaced here, and here the 9th bit will be replaced, and so on. You can see this, in fact, a step is repeated till the last one. Okay, and finally at the end we can put the 1st bit here in the last part. This is the main, in fact, expansion box as we explained here. Okay, and what will happen in our S boxes? This is the stage in which we have substitution. Okay, first of all, our 48 bits is split into 8 parts. Okay, and which each part consists of 6 bits. Then these 6 bits are converted into 4. Okay, the entry or the input is 6 bits and the output will be 4 bits. But how it could be happen? In fact, consider let me change a bit the place of my recorder. Okay, you have in your, in fact, 6 bits, the first and the last one. You pick the first and the last one and put them together in order to show you the number of your rows here, and then it will remain 4 bits. Those 4 bits will show you the column. In fact, the intersection of the row and the column will show your, in fact, output. Let's see in a numerical example here. Consider your 6 bits are something like that, 1 1 0 0 1 0. First of all, you pick the first and the last one, which yield to 1 0. 1 0 in binary is equal to 3 in decimal, which means that you need to pick your third row, first, second, third one. Okay, and for the number of column, you need to put the remain 4 bits here, 1 0 0 1, which is equal to 9 in decimal. Okay, hence you need to go to the 9 column. The intersection of this column and this row will show your output. The output is equal to 12, which will be replaced with 1 1 0 0, which is equal to 12. Okay, hence in this way we can convert our 6 bits into 4 bits. I guess really it is interesting. Okay, and as you can see here, we have 8 SBox. SBox number 1 2 3 and number 8. Hence we need 8, in fact, SBoxes to use in each step. And you can imagine that this number of boxes will increase the confusion of our algorithm. Anyway, and now let's see what will happen in the right side for generating our keys. Okay, first of all, as you can see, for the input we have our key, which is the size of 64 bit. Then we have a permutated choice which yield an output of 56 bits length. Okay, after that we have, as I explained, a left circular shift of this 56 bits. After this shifting, we have a permutated choice number 2, which yields our sub key number 1, for instance. Okay, in fact, the permutated choice number 1, this one, let me write here. This permutated choice is doing nothing, just discarding some bits. In fact, in this step, we discard the 8th bit of our key in each row, okay, which at the end we will have a 56-bit key. Then we put this output and we will have a left circular shifting. And as you can see here, for each round we have different number of shifts. For instance, for the round number 1, 2, 9 and 16, we have only 1 bit shift, and for the others we have 2. Okay, okay, and in this slide you can see, in fact, maybe each step in more details. Here you can see the number of beats for circular, in fact, rotation or shifting, and here you can see the permutation choice number 1 and also permutation choice number 2. And if we need to take a look in more detail, as you can see, we have our key, which will be split in 2 parts after dropping the parity bits. In fact, the first permutation choice only will discard our parity bits, which will yield to this output, 56 bits. Then this part, which we split into shift into left, and right part, in fact. Okay, and then as you can see here, they will be compressed with our compressed debugs to generate our first round key. And then the output of the, in fact, previous step is the input of the next step after circular shifting, and then they are again compressed and output the key of the round number 2, and this will be repeated till the last round. This is the main, in fact, diagram that shows the key generation in each round, in fact.